In this video, the learning target is I can, given a graph of a quadratic function, write the equation. So we're going to look at two specific examples. So in number one, we're given this graph, and you'll notice that we have the vertex. They're telling us the vertex is at 3, -5. Okay, so this is the vertex. And then they're giving us this other point on our graph over here, and I'm going to call that the extra point. Okay, and so what we do when we want to write the equation from a graph is because we're given the vertex, we're going to write the equation in vertex form. Okay, so what I'm going to do is I'm going to fill in the information that I know just from the vertex. So I'm going to get f of x equals a times x squared, and then I'm going to fill in my shifts, right? Because the vertex is based off of the shifts at the end of the equation. So to be shifted right 3, well, that's going to be a -3 in the parentheses, right? That really moves me right 3. And then to be shifted down 5 is a -5 on the end. So I know that in vertex form, I have -3 on the inside of the parentheses, and I have a -5 on the end. So the last thing I need to do then is solve for the a, and that's where this extra point comes into play. The x gets plugged in for the x value, and the y gets plugged in for the function value, and then I solve for the a. So I'm going to get 3 equals a times 1 minus 3 squared minus 5, and then I can simply just solve this equation for my a. So I get 3 equals a times 1 minus 3, well, that's -2 squared minus 5. I'm going to go ahead and add the 5 over to the other side. So I get 8 equals a times -2 squared. Okay, so I added the 5 over, get 8 equals a times -2 squared. -2 squared is 4, so I'm going to get 4 times a equals 8. And then to get rid of the 4, I can just simply divide by 4, and I'll get a equals 8 divided by 4, which is 2. So my a value here is 2. The last thing I need to do then, once I have the a value, is I just plug it back in to my formula. So my function is going to be f of x equals 2 x minus 3 squared minus 5. Now, there's kind of some ways you should always kind of think about checking your work here. So once again, if I think about my transformations, that should take me right 3 and down 5. So if I look at the graph, right 3, down 5. And then if I have a vertical stretch of 2, right, my a value is a 2. When I go over 1, I should go up 2, over 1, up 2. Notice those points hit on my graph. And when I go over 2, it should go up 8. Well, if I go up 8, 1, 2, 3, 4, 5, 6, 7, 8, that hits the point on the graph. So this a value is correct. This would be the function. All right, let's go ahead and look at number 2. So in number 2, you'll notice they didn't give me the vertex, right? I don't know where my vertex is, but I do know where the x-intercepts are. So this time, when I write the equation, I'm going to use intercept form because I know my intercepts. So I'm going to write f of x equals, I don't know the a, but I know where the x-intercepts are. So I'm going to write x minus 1, right? It's -1. It's the opposite of your x coordinate. And then it's going to be x minus 5 because my other one's at 5. Okay, so it's just the opposites of your x-intercepts. Then to find the a value, I used this extra point again. Okay, the extra point I'm going to plug in to solve for a. The x coordinate's going to go in for both of the x's. Okay, so both of those are going to be zeros. And then the -2.5 is going to go in for the y, or the function value. So I'm going to get -2.5 equals a times, well, 0 minus 1 is -1. 0 minus 5 is -5. And then I'm going to get -2.5 equals a times -1 times -5 is +5. And then lastly, I can just divide by 5, and I'll get -2.5 divided by 5 equals a. And if I take -2.5 and divide by 5, well, that simplifies to be -1/2 equals a. Okay, so my a value is -1/2 here. And then I can just simply, once again, plug that in for the a in the function, and I'm done. So my function would be f of x equals the a value, which is negative 1/2, and then x minus 1, x minus 5. Okay, I have x-intercepts at 1 and negative 5, and then negative 1/2 is my stretch. Now, one last thing you can kind of check here, I forgot to mention this on the first problem, is your a value, whether it's negative or whether it's positive, will control which way the graph goes. So that's just something you can kind of check at the end to make sure that you solve this correctly. Um, so because it's negative here, you'll notice my graph should be going down, which it is, right? These arrows here, right? The parabola's going down, and then when it's positive, you'll notice the parabola will now go up. Okay, so that's just another thing you can kind of check to check your work on these problems.